Hi guys, here is a detailed explanatory video on this project topic: accuracy assessment of Google Earth satellite imagery using ground acquired data. So the idea of this project is that we want to see the horizontal accuracy of a particular satellite imagery downloaded from an open source compared to the ground method of surveying. Alright, so the ground acquired data will be used as reference, okay, to fact check the accuracy of the Google Earth satellite imagery of a particular study area. Alright, so just follow me carefully. So the first thing is to, after you understand the topic, you scroll down to the abstract. Alright, so the abstract is a summary of everything that you are to achieve or you have achieved in the course of the project. So we want to see the horizontal accuracy of a satellite remote sensing imagery, okay, compared or using the ground surveying method as the reference. All right, so the idea is that when you download an imagery from a website, maybe Google Earth Pro or SAS Planet, an imagery of a region, you are expected to go on ground and obtain ground control points within that region. So the ground control points, also known as GCPs, is what you are going to be using to georeference such imagery so that you can have it at a known spatial system, that is a known coordinate system, for you to be able to extract features with coordinates and do your comparison. Do you get? So after you downloaded your imagery, you obtain ground control points using real-time kinematic global navigation satellite system, which is the GNSS surveys. So you can actually use total station traversing to obtain features within the study area as well. All right, any which way is okay, in as much it is the ground surveying method, it is acceptable. So the ground control points now will be used to georeference the satellite imagery in ArcGIS, and you will now digitize features, okay, from the ArcGIS software from the satellite imagery. So the features you digitize on the imagery is what you are going to obtain on ground. So that same features, all right, will be mapped or will be observed with the total stations, or you can use the RTK service as well. So in the course of this project, the same features that was digitized on the georeference imagery was mapped, observed using total station. So these two set of data is what you will now use, or what you use to do your comparison to obtain the accuracy of the satellite imagery. Do you get that? So that is the idea of this project. So we will be obtaining same features on digitized map and that same features on ground. Then we'll now compare to see the accuracy of the satellite imagery. Then next, you scroll down to the aim and objectives. So here the aim is where you state what you want to achieve, which is to assess the horizontal accuracy of satellite image, okay, to ground survey methods. So the objective is stated below, all right, to acquire Google Earth satellite imagery of a part of a section of the study area from Google Earth Pro. Then you acquire ground control points through RTK surveys, all right, with the GNSS equipment. Then you georeference the satellite imagery with the control points, okay, that is what you have to do, or that is what you have done. Then I produce the digital map of the study area using satellite image data. Then I produce a digital map of the study area using the ground acquired data. Also, I compare the maps in relative and absolute sense. I am going to show you what I meant by that later. Then to write a technical report of the project. So this is what I followed to obtain the aim. All right, this is the objectives I followed to achieve the aim. So therefore, you now scroll down to the chapter 3, which is the methodology. All right, so on your methodology, you are going to see the first thing is the flow diagram. Data acquisition is the first thing I did. So I acquired the satellite image of the study area. Then I obtain ground control points GCPs with the RTK surveys. Then I use the GCPs to georeference the satellite image. Then I import the GCPs on the georeference image. Then I extract the relative positions of the same features. So the GCP is a features that is obtained with the ground method, and then I import it into the ArcMap georeference image. Okay, then I digitize that same points, the same features on the georeference image. Then I extract it. Okay, so the extracted features, which is the GCPs on the georeference image, is what I now use to do the comparison, okay, which is the assessment of the accuracy of the satellite image. So you can see the process I followed, then I presented my results. So you scroll down, okay, so this is RTK field surveys. This is the satellite imagery I downloaded from Google Earth Pro. Then I will scroll down. The categories of data used is the satellite imagery and GPS coordinates, okay. The equipment and software I use, GNSS equipment, okay, the RTK equipment. So the ArcGIS software is what I use in digitizing and extracting of the features of the ground control points on the satellite imagery. Alright, then I use the Google Earth Pro to download the satellite imagery. So I'll just scroll to the chapter 4. So on the chapter 4, this is where I highlighted all detailed process, exact equipment I use, the GPS receiver I use, and I explained and gave a detail of the coordinate formats I exported from the receivers, okay. And I stated where the table for the observed coordinates is being tabulated, okay, the GPS receiver coordinates, which is a control point. Then I stated the epoch, set up my GPS to obtain observation. So it is 60 seconds, which is 1 minute epoch for the ground control point, okay. And the RTK surveying equipment based on manufacturer specification is equals or less than 1 cm for RTK observations. All right, so this is where I stated it. Then lastly, I gave a brief explanation of the figure for the assessment of the georeference image of what my standard deviation, which is the absolute accuracy of the satellite imagery, turned out to be. So it is plus minus 0.7 and it is actually in meters. All right, so that is the degree of accuracy of the satellite image. I'm going to show you the table that does that. All right, so the next thing is result presentation. So this is my ground control point, which is the field surveys ground method. All right, I obtained this set of controls on ground. All right, so you can see how, so it's a set of 40 points on ground, all right, with the ground method. Then the computation of accuracy parameters, okay, you need the sample mean and residuals. These are the factors you consider or you obtain to get the accuracy of the satellite imagery. So the sample mean and residuals, I computed that using this formula here. Okay, using this formula here, you can consult your textbook. This is the formula for the sample mean for the x variables. Okay, for the y variables, remember the coordinates we have x and y, which is eastern and northeast. So you will compute for the x variables, then you will compute for the y variables. Then you scroll down to the variance. The variance for the x variable is given as this, for the y variables is given as this. Alright, scroll down to standard deviation. So for your standard deviation, this is the formula for standard deviation, okay, for the sample mean. Then you now scroll down. So this is where I computed using Excel. So on your Excel sheet, this is the GPS coordinate from ground surveys. All right, the GPS coordinate from ground surveys I obtained. This is serving as the reference data. All right, then here is the map coordinates, the digitized coordinates. So I imported this set of GCPs into the ArcMap environment, then I digitize it, okay, on the georeference imagery. Then I obtained this set of coordinates with respect to its equivalent ground control points, all right, ground coordinates. All right, so